5.2 day 2. Do these problems here. So we start with the compound interest problem. So number 72 says $35,000, that's what we're starting with, is equal to 4.2%, 3 years compounded first annually, so annual would be 1 times a year, versus quarterly, which would be 4 times a year. Okay, so we want to find both of those there. Put them into your calculator. This comes out to be $39,597.81. This one comes out to be $39,673.81. So the more that it's compounded, the more interest you make. 74. Okay, we're starting with $15,800. And 4.6% compounded quarterly for 6.5 years versus continuously. Oh, I shouldn't use that equation if it's continuously. Continuously, we use A is equal to principal times E raised to the RT. So our principal was 15,800, and E raised to the rate 0.046 times the time, which was 6.5 years. Okay, so when you work these out, this one came up to be $21,270.13. This one came up to be $21,306.45. Okay, 76. We have 2 different plans, which will be better for you. Okay, so plan A, we have $50,000. Okay, compounded daily. Okay, so 1 plus the rate is 0.0475. Compounded daily, which is 365 days for 10 years, versus B, which is still $50,000, which would be nice to have. 4.7%. So 4.75 versus 4.7, and oh, this one also is continuously. So let me get rid of this part. But it's also for 10 years. Okay, so we got to work those out here. Okay, putting those in the calculator. This one here gave me $80,398.23, and this one gave me $79,999.71. So this one is better by what, about $398.52. Okay, so notice it's a higher interest rate. That would trump the continuously versus 360. Okay. So interest rate has a big impact on your return. Okay, so I put the 2 equations in here for number 78. 1,000, and this interest rate at 300 compounded daily, at a higher interest rate compounded annually. Okay, so at 2 years, okay, if we look at 2-year data, notice they're almost the same, right? Notice the green and the purple are really pretty much on top of each other. The green at 2 years is, let me see if I can get that right on 1161.82, and the purple at 2 years is 1161. Okay, difference of like 38 cents. Okay, and then you can check at 5 years what the difference is. Okay, etc. And as we keep going here, we start to see a little bit of a separation, not much. Okay, at 2 years it was 81 cents. At 5 years it's $2.53. At 10 years it was $7.78, 77 cents. At 20 years, okay, so here at 20, if I'm coming up here at 20 years, be around this area here. The difference is about $31. Okay, and if I keep going, I'm going to start seeing a little bit more of a difference. Okay, so it's hard to see that, but there are different, the purple versus the green there. Okay, and when you get out here to 40 years, which is way out here. Okay, at 40 years, I missed it. Right around this area here, okay? So if I go to 40 years, okay, very close to 4 years anyway, there's about $20,000 in that one. And 40 years here, be 19, oh no, the purple would be less. So 14, 19, okay, so there's a difference of like $278 there. So there is a difference between the two. I'll show that on the next screen, but that's how you can kind of look at those two graphs. So you can see here that even though it had a lower interest rate, there wasn't much difference, just after 1 year. But after 40 years, even though it had a lower interest rate, it produced more income because of the number of compounds it had per year. So if it's just compounded once per year versus 365 times per year, it yielded a higher yield. Okay, number 80 gives us this equation for the world's population since the year 2000. So the year 2000 was kind of our initial amount here, and it grew by this amount. Okay, so in 2006, what would we expect it to be? Well, I can take in my equation and plug a 6 in there, I get this. The actual was this, so our prediction was a little bit over 1 million more. Okay, part B, predict for 2010. So I would use this. 2010 would be 10 years later. So I plug a 10 into the equation there. I get 6895.3 million people. Part C, predict for 2025. I want to plug a 25 in there. Okay, plugging a 25 in there. We are 8329.81 million people. This is really billions, right? So in 2010, we're going from 6 to over 8 billion people in the world. Why this model may not be accurate for 2025? Okay, it's something called extrapolation, which means the farther away from our data, the less accurate it may be. Okay, so if we have data like some points since the year 2000, we've noticed it going like this, right? So if I know between here and here, if I know these points, I can't really make a prediction for out here because I don't know if it's going to continue or if it's going to start to level off. I don't really know what's going to happen out there, so too far out there it's hard to make predictions.